Hello friends, I welcome you in lecture number 11 on applications of integration. We have discussed about washer method in lecture number 10. In this lecture also we will discuss one more problem on washer method. In lecture number 10 we have considered the region between two curves and we rotate that region about x-axis, and the formula for the volume of solid was pi times integral of outer radius square minus inner radius square, and integral is with respect to x. Here we are going to rotate the region enclosed by given curves about the y-axis. So our formula will have this form. Instead of integral with respect to x, we will integrate with respect to y, and this outer and inner radii will be functions of y. So we will discuss this problem using this formula: outer radius square minus inner radius square, integral with respect to y into pi. First we sketch the region bounded by these two curves, and for that we can find out the intersecting points of these two curves. So for that we can put y equal to x square in this curve. So if we put y equal to x square here in this equation, then we have x equal to x square square, that is x raised to 4. Therefore we obtain x raised to 4 minus x equal to 0. That means x times x cube minus 1 equal to 0, and therefore x equal to 0 and x equal to 1. And y is equal to x square, so when x is 0, y will be 0. When x is 1, y will be 1. So these two parabolas will intersect at these 2 points 0 0 and 1 1. So if we find out intersecting points, it will be easy to sketch the plane region bounded by given curves. So first we sketch the plane region bounded by given curves. Suppose this is y-axis, here we consider x-axis. We sketch here also. In this part we will try to sketch the solid generated by revolving the region, which we will sketch here. Now first we consider these 2 points which are the intersecting points. Here we have origin, and this is origin 0 0, and we assume that this much scale is 1. So here also we have this point 1 1, and y equal to x square, that is this type of parabola. This is y equal to x square, and we consider the portion of this parabola between these two curves only. So we consider that this is y equal to x square. Let me sketch properly. Just a minute. Y equal to x square may look like this. It should not look like a straight line. And y square equal to x, so that is this type of parabola which opens to the right. So we use different color for y square equal to x. So that will be also passing through these 2 points. So this is y square equal to x. So now we have to rotate the region between these two curves about y-axis. Here axis of rotation is y-axis. So we try to imagine this solid generated by rotating this plane region about y-axis, and for that here we consider that much distance as 1 1, and here we have this parabola. So if we consider the region, we first extend this. Just a minute. I have to go up to this much distance which I have taken here. Okay, so if we consider the mirror image of this parabola, this is y square equal to x, and this curve is y equal to x square. So mirror image of this parabola y square equal to x with respect to y axis. So if we consider this mirror image, we have this type of shape, and if we consider the mirror image of this red graph, here we have this type of sketch. This is y equal to x square, and if we consider its mirror image with respect to y axis, we will have this part, and we join these two so that it will look like a solid which is generated by rotating the plane region which we have sketched on the left side. So this will be the solid generated by rotating this plane region about y axis. So this solid will have is having a hole inside it. You can consider this part only to understand. Our solid will be this portion and this portion only. Between these two, we are having a hole or cavity. So there is a cavity in the middle, and we are interested in the volume of the solid, and our solid consists of this portion. There is no solid in between these two. So to find out the volume of this solid, we consider its cross section perpendicular to y axis, because axis of rotation is y axis. So if we consider this cross section perpendicular to y axis, then we will have this type of cross section. It will be a washer. The cross section may look like this. So we will find out the area of this washer, and you can see this washer is having its area, which is the area between two circles. We are having this type of situation, inner circle and outer circle. So area between two circles is a washer, which we have shown here, because we are having two dimension. If we visualize in 3 dimension, then we will have washer will look like this region between two circles. So area of this washer is area of outer circle minus area of inner circle. So for that we require the radius of both the circles, and center is at the same point for both the circles. For outer circle, this distance is the radius. So that we can understand here. If you visualize, this distance is nothing but distance from y axis to this curve, y equal to x square. So this is the outer radius, and that we denote by capital R. So capital R is the distance between y axis and this parabola y equal to x square, that we can rewrite as x equal to square root of y, and y axis means x equal to 0. So this distance is nothing but square root of y minus 0, that is square root of y. So outer radius is the distance from y axis to this curve y equal to x square, and that you can visualize here also. Similarly, inner radius is the distance from y axis to this curve, that you can understand here. This much distance from this point on the curve to y axis, that is this distance. We can visualize here also. This distance is inner radius r, So distance between y-axis and this curve, which is y square equal to x, or we can say that x equal to y square. So r of y is y square. At this point value of x is y square, at this point value of x is 0. So x minus 0, x equal to y square minus 0, that is y square. So inner radius is y square, outer radius is square root of y. So we have to decide these two things. These two things are main, and for these two things you can decide from the plane region only. Outer radius is the distance between axis of rotation and curve to the right side. Here y equal to x square is the curve to the right side, and this inner radius is this distance from this point to this point. So in this way we can decide the outer and inner radius, and once we decide these two things, we have to decide the limits of integration for variable y. So for that, here value of y is 0 at this point, and at this point value of y is 1. So the limits of integration will be from 0 to 1. So this is main thing. You have to decide the area of washer, and washer is the region between two circles, and therefore area of washer is area of outer circle minus area of inner circle. So radius of outer circle is this distance capital R, which is x equal to square root of y. Radius of inner circle is denoted by small r, which is y square. So once we have understood this, we can easily find out the volume of solid is volume of solid of revolution is v equal to, we have obtained the limits of integration, we have to multiply by pi outer radius square minus inner radius square, integral is with respect to y. Now we put values of upper and inner radius, outer and inner radius. Outer radius is square root of y, square root of y, minus inner radius is y square, square of y square, integral is with respect to y. Now we integrate this. Before that we simplify this. Square root of y is y minus y raised to 4, integral is with respect to y, and this is equal to pi times integral of y is y square by 2, integral of y raised to 4 is y raised to 5 divided by 5. Limits of integration are from 0 to 1. First we put y equal to 1, and we have 1/2 minus 1 by 5. For y equal to 0, this is 0, and LCM is 10, and here we have pi into 5 minus 2, that is 3 pi divided by 10. So it is easy to find out the volume of the solid, which is generated by rotating the region bounded between two curves using washer method, and this is just for understanding. We have sketched the solid, rough sketch of the solid generated by this rotation of this region about y-axis. Okay, we are considering the sketch of three-dimensional solid in two-dimensional plane. So this is just for understanding, and from this we may have the idea that cross section is going to be a washer, and we have to decide the outer radius and inner radius for that washer, and that we can decide in this way. So this is all about this session. I hope you like. Thank you very much.